Dear friends, welcome to my channel. Today we shall see about the transportation problems. So let us open. So we are going to see the transportation problems. Today we are going to see three problems that we are going to solve using POM-QM software. POM-QM for Windows 5 series, version 5.2. Okay, we are going to click on transportation problem. Here you can see below the statistics it is there. Transportation problem example 1. Now let us go and see the problem. So the first example is the ABC Milk Company has three plants located throughout a state with production capacity 50, 75 and 25 gallons. Each day the firm must furnish its four retail shops R1, R2, R3 and R4 with at least 20, 20, 50 and 60 gallons respectively. The transportation cost in rupees is given below. The economic problem is to distribute the available product to different retail shops in such a way that the total transportation cost is minimum. So you can see it is plant P1, P2, P3, retail shop R1, R2, R3 and R4. The supply 50, 75, 25, demand 20, 20, 50, 60 and these are all the rates. So now let us open our POM-QM software. So the number of sources is 3 and destination is 4. So sources is 3, destination is 4. Our objective is to minimize. The transportation cost is minimum, so it's a minimization problem. Source, column name, destination, then click OK. Any starting method. Here you can choose northwest corner method, minimum cost method or Vogel's approximation method. Let us go with Vogel's approximation method here because that gives the best solution. So we are filling all the details. 50, 75, 25. 50, 75, 25. 20, 20, 50, 60. 20, 20, 50. 3576, 3576, 2582, 2582, 3692, 3692. Now we have to click on solve. So source 2, source from source 1, we transfer to destination 3. From source 2, we transport to destination 1 and destination 2. From source 3, we transport to destination 4. Source 2 also to destination 4. This is the answer and the total value is 610. This is the minimum value. We can also see solutions at iterations. You can see how the iterations have gone using Vogel's approximation method. Okay. Now let us go to the next problem. Transportation problem 2. Consider the problem of allocating raw materials from 4 different warehouses to 5 different plants. The availability of raw material in the 4 warehouses are 25 ton, 30 ton, 20 ton, and 30 ton. It is not possible to ship the raw material from warehouse 4 to plant 4 because of steep road. From the unit cost of transportation in hundreds given below, find the optimal shipping plan for the raw material. So now let us go back to POM-QM software. Give new transportation problem example 2. So we have to minimize here over here. Minimize we have chosen. So next is there are 4 supply and 5 demand. 4 supply and 5 destinations. Destination, row names, source, give OK. So 25, 30, 20, 30. 25, 30, 20, 30. 25, 30, 20, 30. 20, 20, 30, 10, 25. 20, 20, 30, 10, 25. 10, 2, 3, 15, 9. 10, 2, 3, 15, 9. 5, 10, 15, 2, 4. 5, 10, 15, 2, 4. 15, 5, 14, 7, 15. 15, 5, 14, 7, 15. 20, 15, 30. Here the value is set to infinity and next is 8. So instead of infinity, let us give a large value 9999 and 8. We'll go for Vogel's approximation method and click on solve. So it says from source 2 to destination 1, source 1 to destination 3, source 2 to destination 4, source 4 to destination 5, source 3 to destination 2, like that it is getting distributed. Source 4 to destination 5. So let us see. Here it should not go to from source 4, from plant 4 to destination 4, it should not go. So plant 4 and destination 4, you can see it is empty. So it has not been allocated. Okay, now we have found the solution and the value is 560 rupees. Now let us see the third problem. Transportation problem 3. Consider the following transportation problem involving 4 sources and 2 destinations. The supply values of the sources S1, S2, S3 and S4 are 100 units, 200 units, 150 units and 350 units respectively. The demand values of destination D1 and D2 are 350 units and 450 units respectively. The transportation cost per unit between different sources and destinations are summarized as given below. Solve the transshipment problem. So here you can see the sources and here are the destination, two destinations. This problem can be modified like this. We have modified the problem here and accordingly we will fill the table 1, 2, 3, 4, 5, 6. 6 and 6. New, click on new in POM-QM software. Transportation problem, example 3, it is a minimization problem. So supply is 1, 2, 3, 4, 5 and 6. Here demand is 1, 2, 3, 4, 5, 6. So sources is 6 and destination is 6. Source 1 column, destination, okay. Any starting method, we go for Vogel's approximation method. So 900,000. 900,000. 950,000, 150. 950,000, 150. 800, 800. 800, 800. Demand is 800, 800, 800, 800. 800, 800, 800, 800. 1,000, 150, 1,000, 250. 1,250. So next are the values 0, 4, 20. 0, 4, 20. 5, 25, 12. 5, 25, 12. 10, 0, 6. 10, 0, 6. 10, 5, 20. 10, 5, 20. 15, 20, 0. 15, 20, 0. 8, 45, 7. 8, 45, 7. 20, 25, 10. 20, 25, 10. 036 036 2018 60 2018 60 15010 15010 10 25 30 10 25 30 23 40 23 40. Now we'll click on solve. It is completed. So this is the status. So 5,250 is the amount that requires to transport from source to destination. So source 1 to destination 1 and destination 2, source 2 to destination 2 and destination 5, source 3 to destination 3 and destination 6, source 4 to destination 4 and destination 6, source 5 to destination 5, source 6 to destination 5 and destination 6. Okay. Thanks for watching the tutorial. Have a great day.